So I'm already done. So here is cytoplasmic structure. Bacterial DNA usually consists of a single circle of double-stranded DNA. Smaller adjacent circles of double-stranded DNA are called plasmid. They often contain antibiotic resistance genes. Ribosomes are composed of protein and RNA are involved in the translation process during the synthesis of protein. Bacteria, which are prokaryotes, have smaller ribosomes 70s than animals 80s, which are eukaryotes. Bacterial ribosomes consist of two subunits, a large subunit 50s, a small subunit 30s. This number related to the rates of sedimentation. Antibiotics such as erythromycin, tetramycin have been developed that attack like magic bullet. They inhibit protein synthesis preferentially at bacterial ribosome subunit while leaving the animal ribosome alone. Erythromycin works at the 50s subunit while tetracycline block protein synthesis at the 30 subunit. Metabolic characteristic. Bacteria can be divided into groups based on their metabolic properties. Two important properties include how the organism deals with oxygen, what the organism uses as a carbon and energy source. Other properties include different metabolic and products that bacteria produce, such as acid and gas. This is the oxygen spectrum. But what oxygen does? Oxygen, how bacteria deal with the oxygen is a major factor in their classification. Molecular oxygen is very reactive. When it snatches up electron, it can form hydrogen peroxide H2O2, superperoxide radical O2-, and hydroxyl radical OH. All of these are toxic unless broken down. In fact, our very own macrophages produce this oxygen radical to pour over bacteria. There are three enzymes that some bacteria possess to break down all these oxygen products. Catalysts break down hydrogen and peroxide in the following reaction. H2O2 it's divided after reaction to H2O plus O2. Peroxides also break down hydrogen peroxide. Superoxide mutates breaks down the superoxide radical in the following reaction: O2 plus O2, both of negative, plus 2H plus. So it can go to like H2O2, hydrogen peroxide plus oxygen. Bacteria are classified on continuum, and at one end are those that love oxygen, have all the preceding protective enzyme, cannot live without oxygen. On the opposite end are bacteria which have no enzyme, pretty much kick the bucket in the presence of oxygen. Obligate aerobes. These creatures are just like us in that they use glycolysis, Krebs TCA cycle, the electron transport chain with oxygen as the final electron acceptor. These guys have all the above enzyme. Facultative anaerobes. Don't let this name fool you. These bacteria are aerobic. Facultative anaerobes, their aerobic name is like anaerobe. Okay. So they use oxygen as an electron acceptor in their electron transfer chain and have catalase and superoxide dismutase. The only difference is that they can grow in the absence of oxygen by using fermentation for energy. Thus, they have the faculty to be anaerobe but prefer aerobic condition. The faculty to be anaerobic but prefer aerobic condition. This is similar to the switch to anaerobic glycolysis that human muscle cells undergo during sprinting. aerophilic bacteria, also called aerotolerant anaerobes. This bacteria use fermentation and have no electron transport system. They can tolerate low amounts of oxygen because they have superoxide dismutase, but they have no catalyst. Obligate anaerobes, these guys hate oxygen and have no enzyme to defend against it. When you are working on the hospital ward, you will often draw blood or culture. You will put the blood into 2 bottles for growth. One of this is an anaerobic growth media with no oxygen in it. The oxygen spectrum of the major bacterial groups. So here is the box about gram-positive negative acid first, no cell wall. So gram-positive obligate anaerobes, nocardia, weakly acid first, bacillus aureus, facultative anaerobes, staphylococcus, bacillus anthracis, gram-positive corynebacterium, listeria, actinomyces. So gram-positive micro aerophilic enterococcus, streptococcus, some species of streptococci are facultative anaerobes. Obligate anaerobes, clostridium, and gram-negative obligate aerobes, Neisseria, Pseudomonas, Bordetella, Legionella, Brucella. Facultative anaerobes, gram-negative. Most other gram-negative rods, aerophilic gram-negative bacteria, Spirochetes, Treponema, Borrelia, Leptospira, Campylobacter. Obligate anaerobes, bacteria, that is acid first, no cell wall, mycoplasma. So chlamydia, rickettsia do not have the metabolic machinery to utilize oxygen. They're energy parasites and must steal their host ATP. Figure 110, oxygen spectrum.